About a year ago, Microsoft announced a partnership with Ampere to deliver their Ampere Ultra ARM64 processors to Azure. Since then, in September 2022, we've also announced that some of those processors are generally available to run workloads on virtual machines and Azure Kubernetes Service. Today, I'm going to show you how you actually deploy a Kubernetes service, which is managed by Azure, called the Azure Kubernetes Service, or AKS, on top of an ARM64 processor from Ampere in the Ultra processor series that they've produced. I'm going to show you some tricks and some tips, and I'll show you a proof of concept for that. This is my Azure portal, portal.azure.com, and if you don't have a subscription, you can get a free subscription there. You'll also find some links for everything I'm showing today at aka.ms/Ampere on Azure. Basically what this is a resource group. This is a resource group that controls and organizes all of the things that I want to have for this particular demo. The Azure Kubernetes Service itself is just a basic Kubernetes service, and it is running a workload which runs Cassandra. I've created a script. Once again, if you go to aka.ms/Ampere on Azure, you'll find this script in a repo, a GitHub repo, as well as some other scripts and some YAML files to deploy to Kubernetes as well. Oh, you have to have the Azure CLI and an Azure subscription to make this work. First thing you do is you set up the environment, you create an Azure Kubernetes service, you created an Azure Container Registry, which is an optional step, or you can deploy from Docker Hub, and I'll show you how to do both. And then you deploy Cassandra to the Azure Kubernetes service. So the first step, we set up some environment variables for the resource group, the location, and the cluster. And then if you want to use the Azure Container Registry, the advantage of using the Azure Container Registry is you can have a private registry, which is secure and has containers that you're going to use inside your organization and can be shared with the organization, but are secure to the outside world as well. And then how do you actually find ARM64 images on Azure? You use the Azure CLI and you use one of these commands. azvm image list all architecture ARM64 table. This query takes a long time to run. So I'd highly recommend picking a publisher. We have Windows, we have Canonical, we have SUSE, and a few others. azvm image list all architecture ARM64 publisher Canonical. That returns a table, which is pretty quick. And I'm going to show you a little bit about what that looks like later. Once you've got that, then you can pick the actual ARM processor image that you want to use underneath Kubernetes that we provide for Azure. And then you set the environment variables for that, a source ARM image and the source ARM image name so that Azure can find it when you want to create this. Then you say AZ group create, you create a resource group. Once again, that's if I go back into the portal, you can see what I created here. This is the actual resource group with everything in it. So you have to create one of those first every time. Next, you dive right into the Kubernetes cluster. So AKS create, this creates a Kubernetes service managed by Azure on the control plane, and you control the nodes and the workloads and pods and things like that. Azure actually manages the Kubernetes cluster, which is the maintenance overhead that so many people find difficult. So you use the resource group you just created, you name it, whatever name you want. You have to add in a location, and then you choose the source ARM image name that you did as part of that search above. This is the trick. The actual parameter that you want to use is node VM size. That's how they specify what the image is that's running underneath the Azure Kubernetes service. In this case, you're going to pick an ARM64 image so that your Kubernetes service is running on ARM. You're going to have a node count of 1. You can scale that later, and then generate SSH keys so that you can set up credentials locally on your local machine. And then if you don't have Kubernetes kubectl installed in your local machine or in Azure CLI, you could do AKS install CLI, and that's going to install kubectl so you can start using it. AKS get credentials is going to grab the credentials for that Kubernetes cluster so that you can write from your local machine or wherever you are at the moment out to that cluster securely. And then here's the optional step of creating the container registry, ACR create. You use the same resource group, you name it the container registry name that you specified earlier. You can choose the same location. The SKU you want is standard. There is a basic one as well, which is free. I can't use that because I've used too many. You're allowed one free container registry per subscription. And then a MID enabled equals true, meaning you can access it from your local machine. The next thing you want to do is just initialize the connection between your local machine and that container registry by saying AZ ACR login. And then you don't have to do this step unless you have a container registry that you've created on Azure. If you want to just go from Docker Hub, you don't have to do this, but you need to connect the ACR, the Azure Container Registry, to your Kubernetes cluster if you want to use a private registry. And that just allows for that secure connection. And it's a really simple command, AZ AKS update, and attach ACR in the name of your container registry. So if you are using the container registry, once again, you don't have to do this if you're just going to pull it from Docker Hub. You just say Docker pull and you grab this Docker Hub image, which I can show you here. It's an ARM64 v8 Cassandra, and it's maintained, as far as I know, by Apache Cassandra, but it runs on ARM64, which is great. From there, on your local machine, you're going to pull it down, Docker pull ARM64 v8 Cassandra. You're going to tag it so you can push it up to the repo in an identifiable way. And you're going to say Docker push my ACR name and then the ACR image that you've defined in your environment variables at the beginning. And the next thing you want to do is just deploy Cassandra to the Kubernetes service. There's two ways to do it, as I mentioned. kubectl create Cassandra deployment grabs it from Docker Hub, and I can show you that. Cassandra deployment, pretty simple. It's just a deployment, a bunch of names and namespaces for Cassandra, and then the image is, wrong one. There it is. The image is ARM64 v8 Cassandra latest. Actually, that's a good example because I'll show you what you do with the ACR in a minute. You grab that one and you set up some ports and it deploys out to Azure. If you want to use a container registry, it's just a slight change. The only thing you have to change is this image. You change the image from this one, ARM64 v8 Cassandra, to the ACR name that you specified for your container registry, the image name, and the image version. And then it'll deploy it from the private registry instead of from Docker Hub. And that's the only difference in these. So if we go back to the actual script, all we have to do here is deploy Cassandra using the Cassandra deployment, and then we set up a service so that it's accessible by external services. And then you can just check the pods by saying kubectl get pods L app Cassandra. That's going to list every app named Cassandra. And then kubectl logs, there's going to be a result that comes back for this, which is the name of the pod. And you just paste in the pod name here and say kubectl logs, and you'll see it's running. For the ACR, it's just using a different deployment YAML file. As you might recall, you just need to change that one value for the container registry. And then the service is unchanged, and you do the same exact command to make sure it's running. Here's what it looks like when you're using it in the Kubernetes service. You go into workloads. You can do this through the command line that I showed you a second ago, or you can go into workloads here in the portal, Cassandra, choose the pods that are running, and you can see Cassandra, it's running, everything's fine. It comes from, in this case, I used the Docker Hub, ARM64 v8 Cassandra. And if you go in here, you can actually do things like check out logs and other things. I won't show the environment variables, but they have live logs as well. So that's kind of cool. All right, so that basically is the 4-step process to deploying a Cassandra workload on top of Azure Kubernetes Service, which is running on an Ampere Ultra ARM64 processor. Thanks for joining. Check out all the notes, this script, all the deployment files and everything else at aka.ms/Ampere on Azure.